This conference will now be recorded.
So we have discussed about the complete LVM objects, the virtual objects, like what is volume group, what is physical volume, what is logical volume, and what is an extent, what are the types of the extents, what is LVM metadata, what is LVM label, where are these located, and what is the importance of this, and how does the internal LVM architecture is going to function, how exactly the behavior of the logical volume manager, how does it understands the utilization of the space, and how does it allocate the physical volumes in the background to the logical volumes, and how does the mapping happen between the logical volumes and physical volumes internally with the mapping of logical and physical states. So these are all concepts we have discussed in the last classes, and today let us discuss more about layouts. So let us start discussing about logical volume layouts. Okay, guys, any idea what is called RAID? Redundant array of independent or inexpensive. That's called as RAID. So we have different types of RAIDs. Don't get confused. Different types of RAIDs means not RAID 0, RAID 1, RAID 5. Those are called as RAID layouts. They're never called as types of RAIDs. They are called as RAID layouts. And today we are going to start with types of RAIDs. We have generally hardware RAID. See, these topics are nowhere a part of syllabus, but without knowing this, if you are going to configure the logical volumes, that makes really funny. That's why we need to know these things. So hardware RAID and software RAID. So let's understand what is called hardware RAID first. If at all you are going to configure any of the RAID configurations on a hardware level, that's called as hardware RAID. Let's say you are buying a EMC storage, or you are buying IBM storage or HP storage. Assume that my storage capacity is 10 TB. My total capacity is 10 TB. I have procured the hardware, it is in my data center, and I started testing it, everything is fine. Now I need to start provisioning the hardware to my clients. So in this case, what exactly I have to do is, before I'm going to provision this hardware, as a storage administrator, it's my responsibility to maintain one level of storage backup as a storage administrator. Forget about the operating system administrators, whether they will maintain the backup or not. So as a storage administrator, he has to do that. So before he is going to provision the storage to the clients, he'll start configuring the RAID. Let's say RAID 1 mirror or whatever is it. So let's say you have to configure a hardware RAID. The total 10 TB is the size of your storage. Once after you apply a hardware RAID, it shows as 5 TB. But because he has already configured a mirror from the storage level, and maximum he can able to allocate to the clients up to 5 TB only. So from the storage level, he has configured a mirror copy, and whatever the RAID configurations is going to configure as a storage administrator, on a storage device, those all configurations comes under hardware RAID. Now, software RAID. Look here, whatever the RAID configurations we are configuring with the help of a software on an operating system are the best examples of software RAID. So what are the best examples of software RAID? Logical Volume Manager, Solaris Volume Manager, Veritas Volume Manager. So in the yesterday's class, we discussed about what is meant by a volume manager software. What are the different types of volume manager softwares available in the market? So using any one of the software like Logical Volume Manager or Solaris Volume Manager or Veritas Volume Manager, whatever the configurations we are going to perform using the softwares, this all operations comes under software. So be very clear in Logical Volume Manager, whatever the operations we are going to perform, this all operations comes under software RAID. In Linux, using Logical Volume Manager, all the operations we are doing with the help of software RAID. So, any questions so far, guys? Okay. So now you are very much aware what is the difference between hardware and software. Now we'll discuss about RAID layouts. We have something called RAID 0, concatenation, RAID 0, stripping, RAID 1, mirroring, and the last one is RAID 5. Striping with distributed parity. That's called as RAID 5. So if you look at our Red Hat official books or somewhere, you will never see this discussions anywhere. You need to know about this. First, let us understand RAID 0 concatenation. I have one physical volume. Assume that /dev/SDB. I have one more physical volume called physical volume 2, which is /dev/SDB. Assume that this capacity is 1 terabyte and this capacity is 1 terabyte. Okay, 100% is free. Now, assume I have one more physical volume 3. Okay, there are 3 physical volumes. Now, these 3 physical volumes are a part of the volume group called VT01. Now, what I'm trying to hit a command is, I'm trying to create a logical volume 01 of size 500 GB. Now, logical volume 01 is being created of size 500 GB on the volume group 01. In our example, every physical volume is of 1 terabyte capacity. We have 100% free space in every physical volume. There are no any physical extents has been occupied yet. This is a new volume group. Let's take an example. So when I hit this command, the logical volume 01 of 500 GB will be created on a volume group 01 by allocating from any one of the physical volume, because our logical volume size is 500 GB only. So every physical volume has more than 500 GB of free space. So the logical volume manager itself will decide which physical volume has to be involved in creating this logical volume 01 of 500 GB size in concatenation. I'll show you one image and I'll explain you more better now. I, I want to explain with our logical volume terminology. That's why I've taken this example. So this disk 1 is of physical volume 1. This disk 2 is, let's say, physical volume 2. Just 1 second. The wrong image. No, this image, whatever you are saying, is confusing. Let me try another problem. Okay. So in this example, we have 4 physical volumes. Let's say 3 physical volumes or 4 physical volumes, whatever is it. In every physical volume, we have around 1 TB of free space. This is a volume group. It's called VG01. Now, we created a logical volume called 01 of 500 GB. So this is SDB, SDC, DRE, whatever is it. So when we hit the command to create a logical volume 01, whichever the physical volume has 500 GB of free space, the logical volume manager itself will decide to choose any one of the physical volume. Why? Because to create this logical volume 01, it requires 500 GB. In every physical volume of this volume group has more than 500 GB. So in this case, only one physical volume is involved. Clear? Take a different scenario. I'm erasing it, guys. Now take a different scenario now. We have same volume group with physical volumes, SDB, SDC, SDD, and SDE. This is our volume group. In this physical volume, I have only 300 GB free space. The same way, in this physical volume also, I have only 300 GB of free space. In this physical volume also, I have 300 GB of free space. In this physical volume also, I have 300 GB of free space. This is a different scenario. Now, this volume group is called as VG01. Now, I am creating a concatenated logical volume, RAID 0 concatenated logical volume called LV01 of 500 GB. Since it is a concatenated logical volume, on which volume group we wanted to get VG01, as soon as we hit the command, the logical volume manager searches for the volume group 01 physical volumes and searches whether any of the single physical volume has 500 GB of free space. If it is available, it automatically creates. But in our example, every physical volume has occupied around 300 GB. In every physical volume, we have only 200 GB left. Here 200 GB, here 200 GB, 200, 200. In that case, how does the logical volume manager creates a concatenated RAID 0 logical volume of 500 GB means the first 200 GB is spanned here, the next 200 GB will be spanned here, the next 100 GB will be spanned here. But I'm not sure 1, 2, 3 order will be like this 1, 2, 3 or 1, 2, 3 or 1, 2, 3. Whichever the order the logical volume manager can take. If you don't include any of the physical volumes, the logical volume manager will decide which physical volume has to be included to create a logical volume 01 of 500 GB. Now, let me clear is, I can explain the diagram, but that is really not easily understanding to you with a scenario. That's why I'm manually writing now. So, in our example, we are going inside the volume group. How does it has been occupied? So, the logical volume 01 has been created. So this is the logical volume, which is called LV01 of how much size? 500 GB. Which one? This one. So how does this LV0150 of 500 GB has been created? This is, let's say, SDB, SDC, SDD. Here we have got 200 GB. Here we have got 200 GB. And here we have got 100 GB. Now I am trying to copy the data. I have formatted this logical volume 01. I have mounted this logical volume 01. I start copying some data A, B, C, D, E, F, G. So A, B, C, D. Until unless, see, now the logical volume 01 of 500 GB is not created from one physical volume. It is spanned across multiple drives. Though the logical volume 01 is created from more than one physical volume, which has different controller plotted on one head. Since it is a RAID 0 concatenation, when you copy the data to the concatenated logical volume RAID 0, the first data copies the first physical volume. Until the first physical volume is filled, the remaining other two physical volumes are idle. Once the first physical volume is filled, then the remaining data E, F, G will be copied. When the data is copied to the second physical volume, the first physical volume and second physical or third physical volume is completely idle. Once the second physical volume is full, then the data starts copying to the third physical volume. When the data is copying to the third physical volume, the first and second physical volumes are idle. Means when you are going to create a RAID 0 concatenated logical volume from more than one physical volume, at an instance, only one physical volume is accepting your read and write requests, and rest all the other physical volumes are idle. Then it really does not make much difference between creating your file system from a single hard disk or creating a single file system on more than one hard disk. Though your logical volume 01 has file system created from three different physical volumes, but at the same time, only one physical volume is accepting the read and write request. Now, when you're copying, only one physical volume is accepting the read request. When you are trying to read the data, first it goes to first physical volume, it searches here. When it is searching, these two are idle. If it is not available, then it goes to here. When it is searching, these two are idle. So, if you really compare the normal file system and RAID 0 concatenated logical volume, Though you span your file system across multiple physical volumes, it may not really show much difference in terms of performance. At the same time, if any of your physical volume is failed, total data of your concatenated logical volume is gone. Just 1 second to make you better understand. I'll just upload one image. I'll just write one image manually. We are not getting a proper images from the internet, so that I'll explain you much better. So if you look at this RAID 0 concatenation, I have a volume group 01 with the two physical volumes, physical volume 1 and physical volume 2. So if the physical volume does not have a sufficient free space, then only the RAID 0 concatenation is going to span on the second physical volume or third physical volume. Please remember very clearly. Let's say my logical volume 01 is 500 GB. If I have 1 TB free space, 1 TB free space, in that case, the total 500 GB is going to allocate from only one physical volume. To create a concatenated logical volume, you require only one physical volume, but it should have a sufficient free space. But in which scenario the concatenated logical volume try to span on more than one physical volume is when the first physical volume does not have only sufficient free space. So I'll just show you while doing practicals also with multiple scenarios. So in this example, we are going to create a logical volume 01 of size, let's say 500 GB. So this has 300 GB free space. Okay, and this has 300 GB free space. So when I create a logical volume 01 and a volume group 01, no option, it has to include two physical volumes. 250 GB from here or not 250 GB. It takes 300 GB from here, the total remaining free space, and remaining 200 GB will be occupied from here. It is like this. So when you format the logical volume and when you copy the data to the logical volume, first data is going to copy to the first component. Once the first physical volume is filled, then only the data is going to copy to the second physical volume. When the data is copying to the first physical volume, this component is inactive. When data is copying to the component, this physical volume is inactive. At the same time, only one physical volume is accepting the read or write request. If you have the physical volume is failed, total data in your logical volume is lost. That's called as RAID 0 concatenation. Guys, any questions about RAID 0 concatenation? Now let us understand what is called RAID 0 striping.
Are we using this concatenation nowadays, sir? In real
See,
time
if you are
scenario?
creating a regular file system, see, if you are not creating a mirrored logical volume, by default becomes concatenation.
No, I know, I understand, but are we using this concatenation?
My
No, we are customizing.
voice is
Mm,
completely disturbing. I'm getting a lot of sound. Maybe some problem with the
No,
earphone. But I understood
my
your
my
question.
que- my question is my
No, no,
question
I
is
understood your question, but we are getting a lot of disturbance. Kindly check your earphones. See, generally, in a production environment, if at all you are creating a file system which is very critical, people will go for mirroring. Simple thing, no? Because as I clearly mentioned, in RAID 0 concatenation, if you are spanning your concatenation on more than one physical volume, any one of the component is failed, the total data is lost. Then your data is not available. If your application needs your data availability dynamic on time, then definitely concatenation is not a solution. Then definitely people will not go for it. So, as per your question, if your file system is for a production environment, then people will not prefer to go with concatenation. Nobody will prefer to go with. If people are using it for test environment, I want to create some file system for test environment. So for that, I'll just go with concatenation. But in a real scenario, nobody will go with concatenation. But to understand RAID 1 mirroring, we need to know about how the RAID 0 concatenation is going to work. Clear?
clear, sir. But how do we mention volume group can be a concatenated volume group or different
Well,
type?
a lot of disturbance is coming, please. A lot of disturbance. Lot of the sound is coming.
Okay.
Can you remove your earphones and try it one more time? So you are asking me about how can we concatenate a volume group? See, this layouts will not work on physical volumes level or volume groups level. This layouts works based on logical volumes level. So we have an option to provision whether it is a concatenated logical volume or striped logical volume or mirrored logical volume or RAID file logical volume, but not as a mirrored volume group or concatenated volume group or RAID file volume group. This layout works on the logical volume level, not on the volume group or physical volume level. Clear,
Got
Bobby?
it. Got it. Got it. So we need to choose the option, no type of volume group while creating the LVM, not the volume
No,
group.
we cannot create a type of the volume group while creating a volume group. We can create the type of the logical volume, whether it is a mirrored or straight or right file, while creating a logical volume. This RAID layouts do not work on top of volume group or physical volumes level. This RAID layouts
Got it.
works
Got
on
it.
top of the logical volumes.
Mm. Yeah. Yeah. Understood. Understood. Thanks.
Okay. So now let us understand about RAID zero striping. See, without these all things also we can complete the practicals and we can finish the logical volume manager. But when you create a striped logical volume, when you create a mirrored logical volume, when you create a RAID file logical volume, or when you create radio stripping, how does the data is being underlined in the background is what you should understand. That's why we're discussing about it. So assume that I created a RAID 0 striped logical volume. Here it is somewhere here. Okay, assume that this is the striped logical volume, which is, let's say, LV02. Assume that, try to understand, guys, this physical volume has, let's say, 1 TB of free space. This physical volume is having 1 TB of free space. Now I'm trying to create a logical volume LV02, which is a striped logical volume, but I did not specify include these two physical volumes. The logical volume manager has included these two physical volumes. Our logical volume size is just 200 GB. 200 GB. It's not something like 500 GB or 1.5 TB or whatever. So I'm creating a logical volume which is striped logical volume of 200 GB, and I did not specify. I have not included any of the physical volumes. But since it is a striped logical volume, the logical volume manager has included to create this logical volume 01 of 200 GB with minimum two physical volumes. Though you have 1 TB of free space, since it is a striped logical volume, the total 200 GB has not been created on the first physical volume. It has allocated 100 GB from here, 100 GB from here. That's called as striping. Now, in striping, when you create a file system on this, when you start copying the data to the logical volume, as like concatenation, the complete data is not copying to the first physical volume. Whatever the data you're going to copy to the logical volume is equally divided into specified chunk size, stripe size, also called as interlace value. So when we are going to create this stripe logical volume, assume that I have given my stripe size as 8 KB. Now let's say I'm going to copy 100 MB of data to this logical volume 02. This 100 MB of data I'm copying to the stripe logical volume 02 is equally divided into 8 KB. 100 MB divided by 8 KB equal to how many parts we'll get? Out of that, the first part is copied here, the second part is copied here, third part is copied here, fourth part is copied here, fifth part is copied here, sixth part is copied here, seventh part is copied here, and eighth part is being copied here. Which means, as like in concatenation, If you wanted to create a concatenated logical volume, you minimum require one physical volume. If your physical volume does not have a sufficient free space, then only you need to use the second or third physical volume. But whereas in concatenation or striping, whether all your physical volumes have sufficient free space to create a striped logical volume, minimum required minimum two physical volumes because your data is distributed across more than one physical volume at a time. How it is being distributed is based on your stripe size. If, in example, if your stripe size is 8 kb, the first 8 kb of your data is copied in the first physical volume, and next 8 kb is copied in the second physical volume. The same way, the data is being distributed on both the physical volumes at the same time. What is the advantage of distributing the data? Means it increases the performance. When somebody try to access the data from this logical volume, now to now this read request in concatenation is only balanced by one physical volume which has one controller, one plot, one header. Now the logical volume is spanned across multiple physical volumes. Since it is a striped logical volume, the data has been equally distributed. Since the data has been equally distributed, now both physical volumes are responsible to perform the read and write operations at the same time. Now, whenever we get a read request or write request to a striped logical volume, this striped logical volume is spanned on two physical volumes which has a dedicated controller. So now two physical volumes are ready to distribute the read and write request, where you can expect a better performance compared to RAID 0 concatenation. So if you look at RAID 0 concatenation and RAID 0 striping, there is no difference in terms of data availability. If in striping also any of the component is failed, the total data is lost on your logical volume. Understood? If any of your component in RAID 0 concatenation or RAID 0 striping is gone, your total data is lost in concatenation or striping. There is no data availability or data redundancy in concatenation or striping. When it comes to the performance of concatenation striping delivers a very better performance than concatenation because in concatenation at single point of time, though the file system can be spanned on more than one physical volume, but single point of time only one physical volume is accepting your read and write request. But whereas in striping, though you're spanning your logical volume on more than one physical volume, every physical volume is accepting your read and write request. That's why your RAID 0 striping is delivering better optimum performance than concatenation. But in a real environment, if you're looking at enterprise file system which is having a crucial data, we will not go for concatenation striping, we will be going for mirroring. Guys, any questions as of now? Guys, any questions? Okay. Oh. Now let us going to discuss about waveform. Yeah. Somebody speaking. If you have questions, please clarify your doubt because these are the basic fundamentals we need to know. Without this, it will be really very difficult. Okay. Just give me 2 to 3 minutes. I'll write a proper diagram and I'll explain you because I feel like that is the easiest way you guys can understand. Guys, look at this. If at all you wanted to configure a mirrored logical volume, let's say this is a mirrored logical volume, this one, LV09, whatever is it. So I wanted to create this as a mirrored logical volume. Assume that the size of your mirrored logical volume is 1 terabyte. So if you wanted to go for mirroring 1 TB of your file system, you require minimum 2 TB. That's called as at least mirroring 1 copy of file system. It's called 1 copy of file system. So to configure a mirrored logical volume of LV09 of 1 TB in a volume group of LV01, you require minimum 2 physical volumes of free space in every physical volume. So it has sufficient free space. So I created LV09 as a mirrored logical volume. So it has used physical volume 1 and physical volume 2 of the underlying physical volumes to the mirrored logical volume. Now you format this logical volume and you start copying the data to this file system, so that the data starts copying to the mirrored logical volume. How the data is being distributed? Not sequentially, parallelly. A, B, B, C, C, D, D, E, E. Since it is the primary physical volume, whatever the data, if later in future if you modify, it will get affected from here, and it automatically synchronizes to the other new physical volume. Let's say if somebody are trying to access the data from the mirrored file system, if any of the physical volume is failed, the users who are the end users accessing the file system from the mirrored logical volume may not be really aware about there is a physical component which is failed inside the logical volume manager. So other physical volume will allow you to access the data. But when you really look at the performance, read is good, but when it is writing, the logical volume manager has to write simultaneously on both the disks, both the physical volumes. So compared to read is fast. Compared to read, writing is obviously slow because the data has to synchronize simultaneously on both the physical volumes. So this is the very easiest example where you can understand logical volume manager, mirrored logical volume, which is RAID 1 mirroring. But again, I don't want to just end up with a very basic example to move up. But I want to make you understand in a real world scenario. In a real environment, nobody will create a single mirror logical volume from one physical volumes. So assume that this volume group 01 has 10 physical volumes. None of the physical volumes has 1 TB free space. In that case, internally, one copy should be concatenated, created from one pool, and other copy has to be concatenated and created from one other pool. I'll just show you that example. So I have a volume group with how many physical volumes? 1, 2, 3, 4, 5 physical volumes. In every physical volume, none of the physical volumes is having 500 GB of free space. Now I'm going to create a logical volume 09. I want to create it as a mirrored logical volume as 1 TB. So assume like if I had any one of the two physical volumes, this if it has 1 TB, if this has 1 TB, then logical volume manager creates this as main copy and this as mirrored copy. Chapter close, like previous example what we have discussed, right? But our scenario is not that. Our scenario is something different. Now we wanted to create a mirrored logical volume 09 of 1 TB from this volume group 01, but it has 5 physical volumes, but none of the physical volumes are having 1 TB. In that case, it include, in our example, it says every physical volume is having 500 GB of free space. In this physical volume, I have 500 GB. In this physical volume, I have 500 GB. Each physical volume has 500 GB of free space. Now, when I hit a command LV09, create a mirrored logical volume in volume group 01 of 1 TB. If I hit a command, what is LVM does is first it searches whether all physical volumes are having sufficient 1 TB of space, not available. Option ruled out. Now it cross check how much free space is available in each and every physical volume. 500 GB, 500 GB. It will understand. And it understand how much logical volume size we wanted to mirror, 1 TB. To mirror 1 TB, we require total 2 TB of free space. So that in total volume group, 500 GB into 5, it has 2.5 TB of free space. Yes, it is possible for us to create a mirrored logical volume. Now, what are the chances of creating? It checks in each every physical volume how much free space is available. Since I have all physical volumes of each 500 GB, so first it creates a mirrored copy. M1 I mentioned as mirrored copy. So to create 1 TB of main copy, it is spanning this logical volume on two physical volume, because to create 1 TB required 500 GB plus 500 GB. M1 from physical volume 1, M1 from physical volume 5. This is one copy. And now it is going to get a mirror copy. Once the main copy is created, it has chosen physical volume 2 and physical volume 3 to create a mirrored copies. 500 GB from here, 500 GB from here. Now, mirrored volume has been created. Whatever, if you look at outside, the logical volume 09 is created as a mirrored copy. But if you go inside of logical volume 09, how the logical volumes are spanned on physical volumes, main copy is internally M1 and M. If you look at main copy M1, physical volume 1 of 500 GB, physical volume 5 of 500 GB. Internally, it is concatenated. We have two sets of concatenated copies. If you look at mirrored copies, 500 GB and 500 GB, internally they are concatenated. That's called as RAID 1. Now, whatever the data you copy to the mirror logical volume, first it copies to main copy, A, B, C, D, E. Once, when this main copy is created internally with two physical volumes, these two are concatenated. These two are concatenated. Once the physical volume 1 is filled, then only this component is accepting the read or write request. Once it is full, then the data is going to copy here. The same way when it comes to mirror copy, also it is being concatenated internally. When the data is full in the first physical volume 2, then only the data is being copied internally. That's called as RAID 0. Now, if any of the component is failed, still the data is available from the mirrored copy, still the users can access from the file system. If really wanted to understand the things very easily and wipe up our hands, we can just see this and you can understand. But even in RAID 1 mirroring also internally it is using concatenation. I wanted to tell you. That's why I have explained you about what is called RAID 0 concatenation and RAID 0 striping. Now if you look at color is not changing. Okay. So if you look at this and this are concatenation, this and this are concatenation. The same way, try to understand. I want to tell you something very interesting and important. If you understand, it is very interesting. I can make this one and this one not as concatenation. I can make this two as striping. I can make this and I can make this as striping. Previously, by default, is concatenation, which means it is a combination of concatenation and mirroring. That's called as RAID 1 mirroring. If you make, instead of concatenation, this component and this component as striping, not as concatenation, this component and this component as striping, then it is going to be a combination of mirroring and striping. That's called as RAID 0 plus 1. That is also a kind of RAID layout. We have RAID 0+1 also, but we cannot configure this type of RAID layouts on our native logical volume manager. It is possible for us to configure RAID 0+1 in third-party volume manager softwares like Veritas Volume Manager. In real world scenarios, this gives optimum performance. Why? Because in concatenation, only one component is accepting the read-write request. When you are going to configure RAID 1 mirror, which is a concatenated mirror, though it is spanning across multiple file systems, only one component is accepting the read-write request. If you wanted to enhance your mirror performance, it is always advisable to go where RAID 0+1, which is a combination of mirroring and striping. For that, you make sure that your underlying physical volumes are striped, not concatenated. To understand this RAID 1 mirror or RAID 0+1, you need to know the concepts of RAID 0 and RAID 0 striping. So guys, any questions for now? Any questions? At least do you guys understood what I wanted to convey? In a regular normal classroom trainings, if you go in Pragati or any XYZ institute in a regular classroom trainings, these topics will not be covered. Since we have sufficient time now, we don't have any specific time to finish. That's why we are learning each and everything wherever there is possibility, because I thought these are the very most important things. But without this generally create logical volumes, we really don't know what is happening in the background. So I don't want to explain about RAID 5. I'll explain RAID 5 by tomorrow, because I need to write a lot of diagrams, then only I can understand for that. So again, I don't want to go offline. So if you have any questions, please do let me know, or else let's go with the practicals. So if somebody asks you what is RAID 1, you should be able to understand, and you should be able to understand internally how it is being concatenated. If you really look at this picture, we'll never get a chance to discuss about whether it is internally concatenating or something. So it depends on the scenario. So this is the real world scenario in an environment where we see. Okay, let me do practicals. So today I'll send you the complete LVM document, including with the labs. So now I'll show you the practicals. So as I told you, the device, the disk, which is under LVM control, is called physical volumes. Whenever you bring the physical volume, whenever you bring the physical disk under LVM, is called physical volume. Every physical volume has a unique PVID, unique UID. So how do you list all the physical volumes in your machine? Use PVS command, or you can use PV display command. So it says there are no any physical volumes yet configured on my system. So in a real world scenario, we use full disk approach. I've explained you what is called full disk approach in the last class. The whole disk, you take it as a physical volume, that's called as full disk approach. In a real world scenario, people use full disk only. So I wanted to know what are the available disks in my machine. I use LSBLK. So this is a OS defined disk. I don't want to disturb it. And additionally, I have another 5 disks: SDB, SDC, D, E, and F of each 5 GB. So now I'll show you how to create a physical volume. PV create is a command to create a physical volume. On which physical volume disk you wanted to create a physical volume? PV create /SDB. So when you run this command, it automatically creates a physical volume label, and also it creates physical volume metadata in the respective locations. So if you use PVS command, it displays. and the type of the LVM labeling it has used is LVM2. So from RHEL version 6, we are using LVM2 labeling. So if you look at partitions available and partitions free, complete 5 GB, because this physical volume is nowhere attached to any of the volume group. It is just recently created. If you wanted to know more information about a physical volume, use a command called pv display dev/sdb. So what is the physical volume? What is the size? Is it allocatable? No, because it is not a part of any volume group. Without adding the physical volume to any of the volume group, it is no use. You can still not see the physical extent size. This all you can see only when you can able to see, when you can able to add under the volume group. And is the physical volume UUID. The same way PV create dev/sdc dev/sdd dev/sde dev/sdf. If you look at this, with a single command, we have created multiple number of physical volumes. PVS command displays all the physical volumes. None of the physical volume has been attached to any of the volume group. Now, I wanted to remove the disk from LVM control so that it will not be called as physical volume. So, metadata and the LVM disk LPV physical volume label will be automatically removed. So, these are the physical volumes as of now. Let me delete the physical volume. PV remove /dev/sdf has been removed. If you give PVS command, it says very clearly F is no more a physical volume. If you wanted PV remove /dev/sde, this also successfully wiped off PVS. You can have only 3 physical volumes. Let me create one more time. Like this, it is possible for us to create new physical volumes and remove the physical volumes. dev/sde and dev/sdf. So totally I have 5 physical volumes. Now my requirement is I wanted to create a new volume group. What is the command is vg create a volume group. What is the volume group name? Whatever the name you wanted. And from which physical volumes? ESDB. You can no need to follow the order. You can add however you wanted. SDC. Now I created a volume group using 2 physical volumes. So if you wanted to list all the volume groups available with minimum information, use a command called VGS. The volume group 01 has been created with 2 physical volumes and it does not have even a single logical volume. And 5 plus 5 GB, it is around approximately 10 GB. If you wanted to know which are the 2 physical volumes a part of volume group 01 means, you can use a command called VG display -P. Let me check whether this command works or not. VG01. Take this command. So you can use a command called PVS. So in a physical volume, it shows very clearly SDB is a part of VG01, SDC is a part of VG01. Like this, it is possible for us to understand. Now, since if you look at the physical volume, B and C are a part of volume group 01, now we'll give PV display dev/sdb. As we discussed more about extents, we spent almost more than 1 hour of time on extents. You can understand the default physical extent size is 4 MB. 4 MB into 1279 is the total size of your physical volume. Any physical extent has been utilized, no logical volumes has been created, so all physical volumes are available for free. So now we have a volume group 01 with 2 physical volumes. And what are the physical volumes? This. How we have now we know how to create a volume group, but now my requirement is how to add the new physical volumes to the existing volume group. Now SDD, SDE and SDF are the physical volumes are not a part of any volume group. Now I wanted to add to the volume group so that I can use it accordingly. That's called as how do you extend a volume group. How do you do that? Extend VG. This is a next command. VG extend. VG extend. What is the volume group name? VG01. What is the physical volume? Dev slash SDD. Dev slash SDE. Dev slash SDF. With a single command, we have added three physical volumes to the volume group VG01. Now, if you wanted to know which are the physical volumes, use PVS command. So now all the volume groups are a part of, all physical volumes are a part of volume group. So if you wanted to use a command called VG display, VG01. How many metadata areas? 5. Each and every physical volume is having at least one copy of metadata which is in first sector followed up with LVM label. And what is the status? Resizable. And what is the total size? This. What is the physical extent size? This much. And total number of physical extents? This much. How many allocated physical extents are there? This much. How many free physical extents are there? This much. And this is the volume group ID. So the same way I will explain you how do we reduce the volume group. How we have explained how do you extend the volume group. The same way I want to tell you how do you reduce the volume group. Reducing the volume group means you are removing the physical volume from the existing volume group. Make sure your physical volume is absolutely for free. It should not have any mapped physical extents. Means it should not have any logical volumes. If you have logical volumes, move that logical volumes or delete the logical volumes. Make sure the physical volume is free. Then you can do that. So PVS. So VG reduce volume group 01. What are the physical volume? Dev slash SDF. Dev slash SDE. Dev slash SDD. Dev slash SDC. I'm removing 4 physical volumes. Or you can give one command also, one command also. If you look at now, we have only one physical volume. Let me see what will happen if I try to remove the last physical volume. VG reduce VG01 dev slash SDB. The last physical volume cannot be removed. Minimum one. What is my volume group? Volume group is a collection of physical volumes. To create a volume group, minimum you require one physical volume. You cannot delete the last physical volume from the volume group. If you wanted to do that, now this physical volume is locked for the volume group. There is no any command to remove the last physical volume from the volume group, but the only way is we can destroy the volume group. VG reduce volume group, sorry, not VG reduce, VG remove. VG remove which volume group? 01. That's all. Now the last physical volume is absolutely available. Understood? Yeah. Now let me do like this. VG create. I'm showing multiple scenarios now. VG01 dev slash SDB dev slash SDC. Now VG create VG09 dev slash SDE dev slash SDD. So totally we have 2 volume groups. VG01 has SDB and SDC. VG09 has SDE and SDD. Each volume group has 2 physical volumes. Look at here. My requirement is I want to merge both as one. VG merge. Okay. Use verbose mode. VG01, VG09. Got it? No more VG09 is available. This is a main one which you wanted to merge with this. So VG01 and VG09 has become as one volume group called VG01. Look at PVS. Previously, it has VG09. Now, if you look at, everything has become like this. The same way we can split the volume groups. Now we have volume group with 4 physical volumes. VG split, divide a single volume group into multiple volume groups. VG01, VG09, from which physical volumes /SDB, /SDC. Sorry. See, opposite I have done this time. Previously, VG01 was having SDB and C. Now I made SDB and SDBC for VG09. So like this, we can perform many activities. We can play with volume group commands. And finally, I wanted to rename the volume group. Let me merge both at a time, and then I'll try to do. I have only one volume group. I want to rename it. VG rename VG01 as VG09. No more VG01 has been renamed as VG09. The same way, if you wanted to rename VG09 as VG01, it's possible. Like this, it is going to go. Now let's get into the logical volume creations. Okay. Do you have any logical volumes? No. Do you have any volume groups? Yes. Do you have any physical volumes created with this? Okay. VG extend VG01. I'll keep all the logical volumes. So I have totally how many physical volumes? B, C, D, E, and F. Total 5 physical volumes. I have each physical volume has 5 GB of free space. Under volume group VG01. Now let me create a command called LV create -L means number of logical extents. Let's say 10 logical extents. See, logical extent size 4 MB. Means the logical volume will be created of size 4 MB. Okay. Under which volume group? VG01. If you look at this command, I just mentioned size under which volume group you wanted to create. I did not specify the name, and I did not specify which physical volume it has to include. I did not specify any layout. When I create a logical volume, if you don't specify the name, the LVM itself takes the default logical volume name. Whenever you create a logical volume without specifying any type of instruction about layout, it takes concatenation. And anytime you create a logical volume without specifying, including the physical volumes, it chooses the best available physical volumes to create a logical volume on any of the available physical volumes. And when you create a physical volume using -L, -l indicates the size of your logical volume which has been created the default naming convention, not in MBs and not in GBs. It is going to create in number of extents. The default logical extent size depends on the physical extent size. A physical extent size by default is 4 MB. So the logical extent size also be 4 MB. So I created a logical volume LV0, LVOL0 default naming convention of 10 extents of size 10 into 4 MB 40 MB. Let's see that. LVS list all the logical volumes. 40 MB has been created. Now do PVS. it has used this 40 MB from SD drive. LV display more information dev slash VZ01 slash LVOL0. So if you wanted to display more information like logical wall 0 created under volume group 01, and this is a complete path, and how many logical extents 10 into 4 40 MB. Segments is one most important thing you should understand, which means this logical volume 0 wall 0 is created on how many physical volumes. Every time you cannot see PVS command, you cannot blindly decide like this. Since all the physical volumes are free, that's why you're able to identify. But in a real world scenario, you have hundreds of physical volumes where everything has been already placed, you cannot understand. So based on the segments, you can understand. So if you still wanted LV display -m dev slash VZ01 slash LVOL0, which is that one segment, which is that underlying physical volume you wanted to know. You can use with -m parameter. That's how you can monitor your logical volume where it has been spanned. I'll tell you one more scenario. I'll delete this logical volume. I'll not keep multiple logical volumes so that you'll not really see the changes happening. LV remove dev slash LV0 VG01. Okay. Now we don't have any logical volumes. Each logical volume is having 5 GB. So when you are going to create a logical volume, by default within concatenation, for creating a concurrent logical volume, one physical volume is sufficient. When your volume group does not have one physical volume having that sufficient switch space, that time it starts creating the second physical volume. LV create, I'm not going to create using number of logical extents. I'm very clear now. I want to create a logical volume of size 6 GB. Why I use 6 GB? Because in my volume group VG01 I have 5 physical volumes. Each physical volume has only 5 GB. If I create a logical volume of 4 GB, it starts creating a concatenated logical volume on only one physical volume. But I want to show you how it starts spanning on multiple. So 6 GB. I don't want to create the default logical volume name. I want to create my customized logical volume name under the volume group called VG01. Now volume group 01 has been created. See here, it has used SDE and as well as SDD. We did not specify itself as chosen. So 6 GB and 1 GB, 3.9 GB. So now whatever the data you copy to the logical volume 01, which is a concatenated logical volume of 6 GB, the first 5 GB is going to copy here. Until this SDE is pulled, though the logical volume 01, which is concatenated created on SDD, is idle. Clear? Now let me delete the logical volume one more time. Previously SDE and SDD are included by LVM. But my requirement is, you see here LV create -L 8 GB, all right, -N LV01 VG01. Now also it decides which is the physical volume, but now I wanted to choose. I wanted to create my logical volume since it is 8 GB, so it involves in two physical volumes. What are the two physical volumes? Dev slash SDC and dev slash SDF. Now I am controlling my logical volume where it has to include on which physical volumes. Now you see here PBS. We did not include it. Let's try one more time. The same command will run. Don't use this command line history for going forward and going backward, since I'm used to these commands I'm using, but I suggest you to type the command. LV01, okay. HT4 signature detector and /V0 LV0 at offset 10550. Yes, okay. We get a file system. So let's see now. PVS. /SDC, first one. Yes, it has taken complete. It is 4 GB. And one more is SDF. 8 GB means this is 5 GB. And remaining 3 GB from here, which is SDF. SDC has 5 GB. SDF has 3 GB. So like this, it is possible for us to include the logical volumes and our required physical volumes, and you can able to cross check like this. And still, if you wanted to get more information, this is not the actual traditional way, it is a conventional way. So you can use LV display /VZ01. This is one segment. This is one segment. Photo segments of 2. Size is 8 GB. Like this. Guys, now tell me, somebody, how do you understand whether it is a concatenated or typological volume? Because this typing means minimum for required. Yes, it is also
Sir,
having.
sir, your voice is sometimes going low, not audible.
Guys, is it the same for everybody? Hello?
Now it's okay. Now it's okay.
Yes, sir.
Yes, sir.
Everybody can able to hear me?
Yes, sir. Yes, sir.
Sometimes it is going very low.
Okay, let me know if any time it is going. So now, if you can look at the logical volume has been created in 2 segments. To create a striped logical volume required minimum 2 segments, 2 physical volumes. So how do you differentiate? Actually, it is a concatenated logical volume, but there are 2 components. How do you make a difference between whether it is a concatenated logical volume or striped logical volume? Anybody? Guys? Shruti? How can you make a difference?
So between logical volume and volume group, you are asking, sir.
Now this logical volume 01 has 2 physical volumes, 2 segments. How will you, let's say you are logging to my system for the first time, I did not told you anything. Can you identify whether it is a concatenated logical volume or striped logical volume? See, generally try to understand, though concatenation is involved on more than one physical volume, until the first component is full, then only the data is copied to the second component. But whereas in striping, it's not happening like that. Though the first component is available for free based on the chunk size, based on the stripe size. The whole data is equally distributed on both the components. At this segment size, you can see one stripe size. Here you cannot see any stripe size here, which is highlighted, which means there is no stripe size, means the data is not distributing. The data is going one after one, which is called concatenation. Because these are the interview questions. Tomorrow when you go for interview, nobody will ask you how do you create a concatenation or how do you create a logical volume. They'll ask something questions like this only. So now let me delete the logical volumes, whichever I had. Okay. Now I wanted to create striped logical volume. Let me create -n. What is the logical volume name? Yes. -I. When you are creating a striped logical volume, you need to specify the number of stripe sets. To create a striped logical volume, minimum you require 2 physical volumes, because the data is being distributed based on the stripe size. Minimum is 2, but it can be more than 2, 3, 4, 5 also. The more the number of components are involved in striping, the more the number of components are distributing the read and write request. The more the number of components are involved, the more performance you can expect. Let's say minimum is 2, but in this example, I'm taking 3 number of component, means 3 physical volumes are involved. -I indicates your stripe size. Your copy 100 MB of data, 100 MB is equal to 8 KB. First 8 KB is copied to first component, next 8 KB is second component, 8 KB is third component. That's called stripe size. It is in KBs. You can give whatever the even number you wanted. And what is the size you wanted to create? Let's say 500 MB. See, in every physical, we have a volume group called VZ01, right? Of 5 physical volumes. Each physical volume has 5 GB. Actually, we have sufficient space in every physical volume to create in one physical volume as 500 MB, but it will not do that. This command involves 3 physical volumes. Okay, 500 divided by 3 with interlace value 8. But which are the 3 physical volumes? It will decide. See now, PVS 1, 2, 3. LV display -m /VG01 / logical volume 01. Very, very important. You got the difference? In concatenation, if your logical volume is spanned on 10 physical volumes, number of segments is 10. In striping, your logical volume is spanned across 10 physical volumes, your segment is 1. That is one way you can understand whether it is a concatenation or striping. But here also it shows very, very clearly striped and number of stripes 3. What is stripe size? Yes. So this is the first stripe, this is the second stripe, this is the third stripe. So for striping, it gives a very clear information. So which are the physical volumes it has automatically involved? dev/SDE, SDD, SDB. Now let me remove dev/ VG01, LV create. Okay. This time I want to create 4 stripe sets. Okay. Of my interlace value is, let's say, 64K. Of size 4 GB. Under volume group 01. What are the physical volumes I want to include? Dev slash SDB, dev slash SDD, not SDC, dev slash SDE, dev slash SDF. So here, your SDC is idle. Rest 1 GB, 1 GB, 1 GB, 1 GB is created. LV display -m slash dev slash VG01 slash LV. Since I have not specified the logical volume name, it has taken the default volume. Segment is 1, stripe 0, stripe 1, stripe 2, stripe 3. That's how it is possible for us. If you want, you can use one more command called LBS -hyphen segment. You don't want to display every information, you want to just display information about the segments of a particular logical volumes. So it has 4 stripes, 4 GB, and under which volume group? What are how many number of stripe sets for this information table? Will be removed. Dev slash VG01 slash LV0. And now my requirement is I wanted to create a mirrored logical volume. So do I have any logical volumes? No. Do I have any volume groups? Yes. Do I have any physical volumes? Yes, all are free. So if you want to create a mirrored logical volume of 500 GB, you need 1 TB of disk space, double the space. So none of the physical volumes are occupied. LV create -m specifies minimum 1 copy. Main copy is 1, mirrored copy is 1. So how many number of mirrored copies? 1 mirrored copy. Right. -L of how much size? 500 MB. I'm creating 500 MB. What is the name of the logical volume? Whichever you wanted, LV01. Under which volume group? VG01. If you wanted, you can include whichever the physical volume also you want. Like dev slash SDB, SDD, like that. See? 500 MB from here. 500 MB from here. This is the same example has been created. 500 MB here. This is called LV0. Now, I'll try to show you this example also. For this. I'll try to show you this example. So, LV remove. I'm not giving multiple logical volumes because I don't want you to get confused with multiple entries. So have no logical volumes. We have total 5 physical volumes. In every physical volume, we have 5 GB, all under volume group VG01. We have 25 GB of the free space. So assume that I wanted to create a logical volume mirror of, let's say, 10 GB. Not 10 GB, let me take 8 GB. So main copy is 8 GB and mirror copy is 8 GB. So each, if you want to create a main copy of 8 GB, I have to involve two physical volumes because my physical volume in our example is maximum size 5 GB. 5 GB plus 3 GB is the main copy, two physical volumes. And mirror copy, to create 8 GB of mirror copy, I needed 5 GB plus 3 GB of two physical volumes to create mirror copy. This total number of physical volumes involved are 4. To make you understand like this real world scenario, that's why I wanted to explain. I know these things create little confusion, but you need, though it is bit confusion, though it is bit tricky, you need to know things which will help you in interviews. So let me do like this. LV create -L 8 gig -M 1 mirror copy only. This is the syntax. What is the logical volume name? LV01. Other volume group VG01. Let it itself choose whichever the minimum 4 physical volumes are required. If every physical volume is having 8 GB, then again it creates one copy in one physical volume, one mirror copy, one physical volume. Yes. Wonderful. See? To create a main copy of 8 GB, 5 GB is required. This 5 GB and 3 GB. 3 minus 2, sorry, 5 minus 3, 2 GB is available. To understand more detail, let's go to, my system is getting stuck. Why? Because the data is synchronizing. Mirror copies, right? That's why. Let me check. We have graph, anything related to LVM processor running. Beta D is the daemon responsible for logical volume manager. It is running. So LV display dev slash VG01 slash LV01. One is main copy, one is mirror copy. This is a mirror logical one. See internally, RAID metadata. RAID metadata. You understood what is this? It is showing very clearly RAID 1. This is the first copy and the second copy. With all information able to see it from here. If you wanted LV remove dev slash VG01 LV01. Everything has been removed. Now my requirement is, let's say LV create. I'm creating a normal logical volume FNL 1 gig in LV01 under volume group 01. MKFS dot 64. If you wanted to use this logical volume, follow with volume group name slash logical volume 01. Format it. MKDIR, let's say SAP. I'm trying to mount it. dev slash vg01 slash LV01 unmounted on SAP. So if you want to display the mounted file systems, you update the file systems information, you mount it, and the file system has been mounted. If you want to copy the data to logical volume, go to slash SAP, copy it. These are all things you are aware about. To make this logical volume mounting permanent, you go to fstab file and you can update in the etc slash fstab file slash dev slash pz01 slash lv01 mounted on SAP. The type of the file system is ext4. Mounted options is defaults. System name and FSC paths, whichever you wanted. Make it permanent. Now go to cd space slash SAP. Touch SAP1, SAP2, SAP3, SAP4, SAP4. So you created 4 files or 5 files. These all files are created under file system SAP is nothing but logical volume 01 of the volume group VZ01. Now, my requirement is this is how you use the logical volume, whether it is a slide or mirror or right file, whatever the logical volume is concerned. We are nowhere concerned with physical volumes or logical volume. We are concerned with logical volume. Create a file system, mount it, and make it permanent. So now I want to create a snapshot on a logical volume which has a file system. Assume we have a logical volume 01 already has mounted and it has a file system and it has been mounted and it has some data. When I try to create a snapshot on such kind of file system, it creates a complete as a backup image, as a snapshot of that particular logical volume of the file system and its data. It can be like a backup. So LV create, we are creating a snapshot logical volume. Size mentioned as 1 GB because we are going to take a snapshot on slash SAP which is of 1 GB. So the destination is 1 GB, so we should take this also 1 GB. Then your logical volume, underlying logical volume of which you are creating a snapshot, you should take minimum of that or more than that, not less than that. -hyphen snapshot. And what is the name of the snapshot? Of which volume, logical volume dev slash VG01 slash LV01. So dev slash VG01 slash LV01. That's all. See now, LVS. This snap is a snapshot logical volume created on the main logical volume 01 on a volume group 01 of size 1 GB. Now mkdir, let's say test mount slash dev slash vg01 slash snap slash test. Go to dff&h. Your snapshot logical volume has been mounted on test. Go to test. You can still access the data. So you don't need to copy your complete file system to some other place if you want to take a backup. Just create a snapshot and keep it aside. If your snapshot created on your logical volume has a file system and the data, the same has been replicated in the snapshot also. That is the beauty of the snapshot. Hope you guys understood. So these all things are really very interesting if you are able to practice these things at regular intervals. And last one thing is we need to discuss about if you wanted to unmount your file system slash SAP. To make this file system unmounting permanent, go to etc slash fstab file. Delete the logical volume entry and let me unmount slash est also. That says it is busy. If it is synchronizing, Okay. Short of course. Now all the file systems has been unmounted. Okay. Not unmounting. That's fine. You leave it. I just keep on, it's not unmounted. Then you see what I'm trying to do. LV remove // vc01 / lv01. I'm trying to delete the main logical volume. Understood what I'm saying? When I am trying to delete the logical volume 01, first it automatically deleted the snapshot, which is a snap logical volume created on this logical volume. And then it is asking us to delete the logical volume. That's what I wanted to show you. You don't need to see, you are creating manually the snapshot. Now, from now, everything, whatever you copy to your file system will be automatically synchronized. That's why when I try to unmount the snap logical volume, it is busy. That's why I killed all the open process and then unmounted manually. So when I'm trying to delete the logical volume, the underlined snapshot logical volume, which is created a snapshot on the logical volume, is being deleted automatically. So, we don't have snapshot. That's how it is going to do it. Now, the last thing is write file. LV create hyphen type is write file. L create a logical volume of how much size? Let's say 5 gig. Number of stripe sets, stripe size. What is the logical volume name? Whichever you wanted, volume group. So it takes some time because it has to create a distributed parity. Now it will be synchronizing. PV display -m /vc01 /lv01. Sorry. LV display, it is slow because it is constructing the distributed parity. That's why. /vc01. Segments is one. It is write file is also a combination of striping with parity, striping with distributed parity. That's why, though there are so many segments involved, the number of components are in segments are one. It's showing. So you can see write file. So tomorrow's class I'll show up with the image and I'll explain you how these commands are going to function. So if you wanted to format, use mkfs command, or you can mount it, make it permanent. I don't want it, LV remove. /down /vc01 /lv01. I'm trying to delete it. Just give me 1 minute. I'll just upload one image. So I don't want you to by heart the commands. I want to learn things easily. That's the reason I wanted to show you these diagrams. Look here. I'm now explaining about so I'm creating a logical volume of 2 gig under the volume group called VG01. Let's say I'm trying to create a directory called Oracle. Before that, I'm trying to create mkfs.ext4 file system on dev slash this logical volume. So I'm trying to mount it on dev slash VG01 slash LV01 on Oracle. To make it permanent, I'm going to update in the etc slash tab file. What is the device to mount? Slash dev slash VG01 slash LV01. And what is the mount point? Slash Oracle. What is the type of file system? ext4. What are the mount options? Defaults. File system dump and FSK pass, whatever is it. Yeah. This has been updated. Now I'm trying to copy some data to my file system. So the data is keep on copying. Means my file system is in use. Let it copy. Okay. Your DF specific H. So till now, around 154 MB of data is being copied. The background is copied. 201 MB of data. So it is not SSD disk. That's why it's going slow. Let it copy how much it is going to copy. Now, my file system in the background is in use. There are few people who are accessing the data, reading or writing, whatever is it. It is happening. Assume that my file system is 100% full. Assume that it is 100% full. Now, without uploading this file system, without disturbing the users, without losing the data, I wanted to increase my file system from 2 GB to something else. So how it is possible for us to extend the file system and to resize the file system with a single command? So for that, I've created one image. We can increase the file system in logical volume manager using two methods. One is grow to, one is grow by. Grow to decides after extending and resizing the file system, what is your maximum size of file system should be. Grow by means you are least bothered about what will be the completed size. So the existing size, how much you are increasing by, that's called as grow by. If you look at now, in our example, our original volume is of 2 GB. Assume it is full. I don't know how much size I'm going to increase. After increasing, it should become 6 GB. That's called as grow to. So after it becomes 6 GB means actually we are increasing 4 GB. But we are never specifying that we are increasing 4 GB. We are specifying it should become 6 GB. The final size should become 6 GB. That's called as grow to. Now assume that our file system size is 6 GB and it is full. To the existing 6 GB, I wanted to add additionally another 4 GB so that it becomes 10 GB. But I'm not specifying 10 GB. I'm specifying I have to increase by size 4 GB. That's called as grow by. So now let's see those practicals so that you'll understand. Okay. So still the data is being copied in the background. So let it do that. No problem. We are not bothered about it. Now we'll see grow to LV extend. This is the command which used for extending the logical volume. As soon as you extend the logical volume, you need to grow the file system. You need to resize the file system. Resize the file system of how much size? We are going to give LV extend -L 6 GB. Of which logical volume? /VG01/LV01. I'm not specifying plus symbol here. That's why now mine is 2 GB. It is going to 6 GB so that in the back end it is going to extend or increase 4 GB. Total will become 6 GB. In the back end, look, the users are accessing here. There are some operations happening here. Without interrupting that, my file system has been grown to 6 GB. Already it was 2 GB. We have grown to 6 GB where 4 GB has been increased. The same way, that's called as grow to. LV extend, resize the file system -L plus 4 GB. To the logical volume dev/VG01 LV01. That's called as grow by 6 GB plus 4 GB has become 10 GB. Still, in the back end, there are users who are accessing the data. We can still go to cd space / Oracle. You can see the data is available. The same way now, I'm closing this. I have a lot of data. What is the size? 10 GB, right? Now I'm explaining about reducing. We can reduce the file systems in Linux using different methods. One is shrink to, one is shrink by. As same as the grow to is shrink to, as same as the grow by is shrink by. Now a file system is 10 GB. I want to make it as 7 GB. Means we are reducing, actually 3 GB, but we are not mentioning 3 GB. We are specifying shrink to 7 GB. Now a file system is 7 GB to the existing 7 GB, shrink by 4 GB. 7, we are specifying 4 GB. So that automatically becomes 3 GB. We cannot reduce file systems in Linux dynamically online. If you wanted to shrink, we have to unmount it and we have to reduce. We have ext4 file systems, we can reduce it, but we cannot reduce it dynamically. We have to reduce it by unmounting. We need a downtime for that. The moment we unmount it, the moment the users will not be able to access the file system, so which will be called as downtime. You have to plan this activity in advance by informing to all your users. And you have one more file system called XFS. XFS file system can be increased but cannot be reduced. Extended file system can be possible to reduce, but it can be done only offline. I'll show you once this thing also. The file system is already 10 GB. It has a data. Again, I'll create one more file, test space. It created one file. So without losing the data, I wanted to. Okay, privacy file has been created. Now look here. LV reduce is the command now. LV reduce. Same command. I can resize the file system. -L. Now the current is 10 GB. Make it as 7 GB. And what is the logical volume? dev/vg01 lv0. But if you look at the file system is mounted. If you wanted to reduce the file systems, see, if I use LV reduce command with 7 GB, this logical volume with the respect to size, it is going to make it as 7 GB. It is asking, you cannot reduce the file systems dynamically. So just give us, it will unmounts, extend the logical volume, resize the file system, again brings the file system back to the mounted state. You don't need to do manually, but these all things will happen automatically. That's the beauty of this command. Now it becomes 7 GB. Same way, LV reduce hyphen resize the file system. Now I wanted 8 GB. I wanted to reduce by 4 GB. See here, the file system becomes 6 GB. Like this, it is possible for us to perform all the LVM commands. So LVM is one of the big chapter. If you want to learn concepts, still there are lot many things we can learn in FSCK. And then ending up our FSCK classes, and I'm not really sure